Katerina and Tom want to buy a rug for a room that is 12 by 19 feet. Careful, we're going to say this is 19 feet. This is 12 feet. They want to leave an even strip of flooring uncovered around the edges of the room. How wide a strip will they have if they buy a rug with an area? Did you look at viewing examples of this? So here's the rug, 120 square feet. I want this to be even area all the way around. So we have to figure out what's our, or how wide will that be. Off-topic story, kind of on-topic story. At my old house, there was carpet down, and we decided to pull it up. Because we like pull up the corner, and there was hardwood, like old school hardwood floor under it. We're like, oh, that's great. And so we pull up like one whole room, and it's okay. And then we go into the next room because it's all connected. And we keep pulling, and then all of a sudden, there's all this floor that's not stained, like the rest of the room is stained. And like we keep pulling, and there's a giant, apparently there was a giant area rug. And they decided when they were staining the floor, they would just go around it, and they just left this giant part of the floor unstained. And so we had, like, we couldn't save it, because like, you couldn't get the stain off the other floor, and you couldn't match the stain, and we went and rented one of those things. That was the plan, but it was just so old, and it was just awful, and there was just dust everywhere. It was crazy. But anyway, I'm like, who doesn't just stain, like, who doesn't just pick the rug up? It couldn't have been that much more stained, right?
Like when you see
That is true. Okay, so we want this to be even strip. So what I imagine is this strip. I don't know what it is, but I would call that X. I could call this X. So if this whole room was 19 feet, and I take X off each end, then my rug would be 19 minus 2X feet. True story? If this is X, and this is X. And I could do the same thing this way. If this was 12 feet, this is also X, right? Because it's the equal length. So this is X, and this is X. So if this was 12 feet, then this little section of my rug would be 12 minus 2X. So the area of the rug I know is length times width. I know the area is 120, and my dimensions are 19 minus 2X and 12 minus 2X. So that was, I think, the hard part of this problem, is you had to set it up. Then you have to FOIL it all out, subtract the 120 over, and then do the quadratic formula, or the square, or factor. So did you do this, Savannah, and you still didn't get it to work? You got it to work. Oh, and then, could do the quadratic formula. And you get two answers, right? What are the two answers you got, Savannah? I really want to do the quadratic formula. But let me just make up two answers, okay? Don't write this down. You're going to get two answers. One small number and one bigger number. So, you say, well, do I just pick one? It only has room for one answer. I don't know what to do. You have to think about the problem here. Could there be a 2-inch strip taken off, or 2-foot strip, I mean, taken off each edge of that? That could. Could there be an 8.5-foot piece taken off each end of that? That would be 17 feet, and this room is only 12 feet. So you can't take off more than when it would double to be the room length. So one of those answers is not going to make sense in the problem, and your answer is going to be the smaller number. Look how I think about the domain of the problem. The domain has to be bigger than 0. You can't take off 0 strips each side, but it has to be smaller than 6 feet in my example, or in my problem, because if you took off 6 feet from both sides, then there would be nothing left. There'd be no rug. I mean, that'd be a pretty silly rug if it was 5.5 feet, but still. Okay. Other than that, was homework okay? Good. Let's take some. When's the last day to retake your test? Thursday. Thursday.
We have 3 days. Whoa. So that's that one, right? What is it?
Oh, Jesse.
Yeah, it's
Okay, so we're going to talk about power functions, monomial functions, and then some applications like direct variation, inverse variation. Remember those things? Like y varies directly as x. I guess you got enough. So Mr. Gresham tell you about his new school. It's terrifying.
yeah. Oh, there's only been 3 fights. They've been at school for like 3 weeks now.
I don't know. It's a charter school. They have like elementary on the first level, and then there's like a school on the second level that he teaches that. And then there's like a tech school on the third level that he teaches that. He teaches pre-cal, but he teaches it at 2 different schools. There's one on the second level and one on the third level, and like the schedules overlap, and so he has to like find investigators and so, like watch his class, watch his one class, and go to the other class. Here's why people should.
Yeah, so you see something that's perfect.
Okay. A power function. Any function that can be written in the form k times x to the a. Why is your laptop over? Shut it. Shut it down. Where k and a are non-zero constants. So the only requirement to be a power function is that a can't be 0. And that k can't be 0. Or otherwise, we don't really have a function. Which means a could be negative, a could be a fraction, right? So any kind of exponent there works as long as it's not 0. We call the constants, oh, the power, that's very surprising. The k is called the constant of variation. We'll do some problems in a minute where you have to find the constant, or the constant of proportion, or the constant of proportionality. Debating on the reply, and I just decided I wasn't. Okay, good shot. There you go. Are you ready? No. There's good parts of it too. I mean, think about Indy, right? Indy's for some pretty shitty areas too. every day on the news someone gets shot. Like, I don't know the last time I watched the news that they weren't like, 2 people shot overnight.
This is
Yeah, I
school
thought-
environment.
I think
they don't go.
I think it shows how like everyone's like, oh, everyone can get an education, but like it's in certain areas, like they can't even get teachers to stay there. You know, like it's like you can say, well, they have the same experience that people on the north side can have. Well, they don't, because on the north side, people are a lot richer, and that money goes into the school, so probably that's there. And on the south side, it's not. And so it's just this whole like saying everyone has the same opportunity. They don't, because they have private schools, and you know, like I'm just saying, like this whole thing that like us living here in Indiana, we can say, well, you know, in Carmel, their schools are way nicer than us. Maybe their schools, maybe they're like, but like it's not the same. To me, it's not the same like inequality that's happening in those places. And like Mr. Grexel was saying that there's, I don't know the name of all the schools. He talks, Mr. not like I'm not Chicago, but there's a school that's a really nice school on the south side that's only at 40% capacity. So you think, why don't they move some of the other schools that are overpopulated to there? They can't because of gang lines, and there would just be people killing each other because they can't have the gang from this side coming across town and go this way. It's just that we don't think about it in our happy little country.
I'm sure there's
Because of gangs. I know, I'm with you. In the handbook, you can't wear bananas. You also can't wear bananas, but bandanas. Because it might have gang reference. Banana gang, that's the best thing ever. Okay. I'm recording all of it. Banana gang, I'll just say that. Determine if the function is a power function. Here's the part that's tricky about this. Given that c, g, k, and pi are constants, state the power and the constant variation. So, number one, hopefully, isn't so bad. Is this a power function? A number times x to a power. Yes. The power would be, and the constant would be. Then what happens when I give you all letters? Right? Like, you know this formula. At least you've heard of it, I'm sure. E equals mc squared. So it says state the power and the constant of variation. So this is where reading the directions is important. It tells us that c, g, k, and pi are constants. So the constant in this equation is... It tells us that c is a constant. So if you square a constant, it's still a constant, which means the variable in this is the other hint, the variable is m, because if you think about if you have f of x, right? Like that's your variable. So e of m, that's your variable there. So the power is the constant is c squared. This is my constant. Because it tells me c is a constant. Do you know what c stands for in this equation? Acceleration due to gravity squared. Acceleration is always the same on Earth because acceleration due to gravity is the whole thing. Gravity doesn't change on Earth. So that means this is my variable. So what is the power on that variable? It's just these. This is like my dash. Sorry, but then I did that thing. I'm with you. It was bad. So that was tricky, right? What about this one? Is this a power function?
Yeah.
To be a power function, you have to have a constant times x to a power.
No.
That has a number to the x power, not x to the number power. So this is not a power function. It's like 12 pages of this. Okay, so power function is just any number times x to pretty much any power except for 0. Monomial function is like a more specific power function. So a monomial function can just be a constant. Or, hey, that looks like power function, right? But they have a lot more rules on this one, right? Remember in a power function, that exponent could be anything but 0. To be a monomial function, n has to be a positive integer. So that means no negatives, no fractions, right? Kind of like polynomial function. Monomial function. So all monomials are power functions, but not all power functions are monomial functions. Oh, that's like dumb. True story. I don't think that's true. Alright, determine if the function is a monomial function. If so, state the degree and the leading coefficient. Sean, you're up. Number 4.
Yes.
Degree. Leading coefficient. Oh my gosh, you're a rock star.
What?
A rock star.
Yeah, no, so we are.
So why are you sitting there?
I don't like I'm just here for like a week. I mean, I sing it this way.
Oh yeah, I remember. We had that conversation.
Big,
I think I don't have even that. Well, anyway, Justin, what about number 5? Why? Okay, now the variable to the number, right? Okay, let's get to the meat of the lesson. That was just the intro. So what do we do with these power functions and monomial functions? There's a lot of stuff, especially in science life, that uses direct variation or inverse variation. There's chemistry stuff, so small about the pressure is inversely related to the volume. So when we talk about these, there's really like 3 types of variation that we want to know. Direct variation is just when you have a constant times a variable. So we say y equals k times x. I call k that constant of proportionality, or whatever we call it over there. So usually, to see this, it says y varies directly to x, or it might say y is directly proportional to x. Sometimes it even just says proportional, like the word directly isn't in there, but it means it's just some constant times some variable. We also have inverse variation. Inverse variation just means that you're dividing by the variable. So inverse variation is the equation k divided by x, again where k is your constant. And it's really easy to know when you're doing inverse variation because it says the word inversely in the problem. It says y varies inversely, or y is inversely proportional. So if it says the word inversely, then you know, oh, that's inverse variation. You just have to know to divide it. And then joint variation is when you have 3 variables instead of 2 variables. So notice all these are the relationship between x and y. Joint variation is kind of like direct variation, except for there's 2 variables. So z varies, and again, it uses the word jointly, as x and y, and you're just going to multiply that x times both of those. Or is jointly proportional. I don't know why I made you write the word proportional on that one, but not really. So really it's all about recognizing which model it is, plugging in the right letters, because when I taught this in Algebra 2, all of them were x and y and z. But in calculus, they're going to give you things that aren't x's and y's and b's, and you have to figure out which one is still in. And you plug in the information, solve for k, and then you can do other stuff. Okay, ready? So it says, write the statement as a power function. Use k for the constant unless one is given. Alright? So, oh my gosh, it's geometry. It says, the area A of an equilateral triangle varies directly as the square of the length s of its side. With all words. So if I see varies directly, I know it's in that format, and I'm going to start with our x's and y's, and then we'll substitute in. But that's the equation, y equals some constant times x. Normally we say y varies directly as x. On this one, we say the area varies directly. So A should be my y. As the square of the length s of its side. Is that s squared or that square root of s? So there's going to say the square root of. And I don't know what k is, so I'm just going to use k. Actually, I think it doesn't tell us this, but k is up here. That's a geometry formula that you learned a long, long time ago. Probably that's true. So on these, you're not even doing anything. You're not even solving for k. You're just practicing writing. Let's do that. Oh. A speed p of a free-falling object that has been dropped from rest varies as the square root of the distance traveled d, with a constant of variation at k equals square root of 2. Is it direct variation, inverse variation, joint variation? Right, it doesn't really say, which means directly. Directly is the one that sometimes they leave the word out. It just says it varies, which means directly. If it was inversely or joint, it would have to say that. So again, this is my model that I'm going with. I could even go as far as, look at this, it tells me right there what k is. You just got to figure out what is y and what is x. It's always like the first thing varies, that's the second thing. So what should y be? Because the speed varies as the square root of the distance traveled d. So x would be the square root of d. So can I just put it underneath here too? Or you can put square root of d next to it. It seems kind of silly when they don't have us do anything else with these, but homework is like this, so I thought we could do it. That's a y. No, it's a g. You're right. But I totally made it a y. I think no, because that's changing your domain, because right now d couldn't be negative, but if you squared it, then it could. So I think no. Okay, so let's do one we actually have to solve stuff. The power P in watts produced by a windmill is proportional to the cube of the wind speed V, 10 miles per hour. If a wind of 10 miles per hour generates 15 watts of power, how much power generated by winds of 20, 40, and 80 miles per hour? What happens is that people try to do this all at once and they get overwhelmed because there's a whole lot of information in these problems. And so I think it's kind of nice that we did one before, because step one is like you find the model, you plug in the letters. Step two is they give us information so we can solve to figure out what k is. Step three is actually plug in what they're asking us. Alright? So Savannah, I interrupted you over here. Because look, it's proportional to the cube of the wind speed. So it's not just proportional to the wind speed, it's proportional to the cube of the wind speed. It's direct variation. So like I'm going to say, instead of y, I'm going to say p varies directly as, I can't just say v, because it's the cube of the wind speed. So I'd have to say v cubed, right? We need to find what k is. What we know is for this windmill, a wind of 10 miles per hour generates 15 watts of power. So we can plug in those numbers and we can solve for k. So 15 watts of power, that's my p. And the wind speed is 10. So I get that k equals 3 over 200, is that true? Or b decimal over 15. Or leave it as 15 over 1,000 on it. They probably would fit. But it just asks us how much power is generated by these numbers. So if you can find your model and you can find k, all you do now is plug the numbers in. So now I can say my model is 3 over 200 times b cubed. Now I just want to plug in 20, 40, and 80 and see how much power I'm getting. So I can say 3 over 200 times 20 cubed, 3 over 200 times 40 cubed, and 3 over 200 times 80 cubed. 80 mile an hour. Yeah, that's got to break the so this one, I got 120 watts of power. And then I got 960 watts of power for 40 miles an hour. And then 80 miles just seems a bit absurd. 7,680 watts of power. I don't know. I mean, but I don't like when I buy light bulbs for my kitchen. I buy like 120 watt bulbs.
A window.
Savannah. You should ask Mr. Rhodes that question. I think you'll be way better at it than I am.
I don't like that.
I bet you was expecting some question.
So, you have homework online that's like 5 questions, but then also, remember I said I felt like our sales this year because our these are questions that I felt like online homework is not challenging for them. These are not extra questions to go with it. So, both are homework. Online homework 5 questions. These discussion questions are 3 questions. That's the homework 8 homework questions. what you did on it, and then we'll discuss it next time on the next section. I will take it to you. Goodbye, gang.
Why would we?
Because this is what it says, the volume varies inversely because of the inverse ratio. That is my favorite friend, so they overlap. So, I gotta say this in the microphone. So, you have to do the discussion questions plus the online homework. And don't join a game.
Hey.